And let me introduce it then. Okay, hi everyone. We are doing some Wolfram language design discussion about, well, today it's about lazy lists. And this is part of a series of meetings that we're going to be having about various kinds of large-scale framework updates or innovations that we're looking at. And so this is one of them. Okay, Roman, go ahead. Tell us about it.
Okay, so the history of lazy lists is quite old. So I started at the first study of lazy structures. Then Leonid wrote a big package which has a different emphasis on different aspect of laziness, which we'll also talk about today. And the latest one that sparked this discussion was a recent series of presentations by Nick in the multi-computation meetings about laziness.
Okay.
And so the goal after that meeting series was to propose to support lazy lists as first-class objects that, as much as possible, will behave like lists.
Yep.
And so lazy lists are obviously, the idea is that elements need not be manifest. They can be infinite. They can reside out of core.
Yeah, I mean, we've made some progress on what this should look like. So let's, go ahead.
Yes, okay. So the implementation is all contained in that single notebook. So it is obviously a prototype. So it will not look as nice. I mean, Nick has some very nice formatting for these things, which we certainly will reuse if we decide to go ahead. And so the current idea is to have a headdress for the constructor, and then map will just work for lazy lists as it does for ordinary lists. Select works the same way. Take, that's something we need to discuss today, whether take should return an ordinary list or lazy list. And obviously part will also work. Now, there isn't a single implementation that will fit all purposes. And that's why the main part of the proposal is an interface. That means that everything that satisfies that interface will be a valid lazy list that can work in this same way. So here's an example of a cached version of the list-like lists. And obviously the advantage of caching is if you access the same element again, then it will be instantaneous because it only produces it once. I mean, that otherwise these immutable versions of lazy lists always suffer from repeated recomputation of things.
Sure. Yep.
So the main types of laziness that we want to cover in this with this general interface is runtime laziness. So essentially means the kind of Lisp-like thing, first rest, where the rest is only computed when needed. There is a small designed question about whether even the first element shouldn't be manifested when you create a list, and we certainly want to support both of these types. The other type of laziness that Leonid has worked on is out-of-core data, or data that doesn't even exist anywhere, because if you have a function that is very fast to compute the data, then there's really need to actually store the data up front. And even if you need it multiple times, it would be faster and more efficient to actually compute it only when needed. And obviously these things can be combined. And one of the implementation details are the chunks, which make it much faster to work with out-of-core data if you don't have to access the disk for every single element. So there's one thing if you have that kind of standard way of laziness where the first element is manifest, and here is an example where this might lead to problems. So if I select the even primes, then obviously it works at first, except that I didn't define my primes up here. So here they are. So here, so if I select the even primes, then it will manifest the first element. So if you take the rest of that list, which is empty as we know, but it will run into an infinite loop because there is no second element. So that's one thing that's a consequence of the infinite and partial function.
So yes? What? I don't understand. What's wrong with that?
No, I mean, it's not wrong. It's just if you expect things like that, then you might want to go fully lazy, where you only compute the first element when you actually need it. But
well, I understand. It's a hack in this particular case. Then it will return something as opposed to returning nothing because there are no additional even primes.
Well, if you take the rest of a fully lazy list, that operation will not do anything, and so it will be instantaneous. But obviously,
it'll return another lazy list.
Yeah, a fully lazy list, yes. And only if you then, for example, ask whether it is empty, would it then run into the same infinite loop.
Well, fair
so
point.
It's just postponing the problem.
Right. So the question is, and that relates to your take comment as well, is, by the time you're asking for the 11th element of the list, you could say, oh, I don't know what that is. Compute it later if you need it. But at some point, things are going to have to be computed. And arguably, there should be a function that, like normal, so to speak, that just says, that nails, hey, is it?
Yes, and I mean, we look at the set of functions supported by LazyList, and obviously something like first or part is something that better deliver a result, right? I mean, otherwise, I mean, why do you do it if you don't actually need it? So, I mean, that was the kind of...
Well, but this is your argument here. I mean,
No, I mean, the question is, I mean, here, for example, no, it's slightly different, because when I asked for the rest of the list, if it didn't insist on producing the first element of the rest, it would have worked.
Yeah.
Right. I mean, the basic point is that the things that cause it to be actually computed are basically indexing and take right now. Although I would kind of argue that take should probably return another lazy list, and you should use normal to manifest it. But yeah.
This was a discussion point exactly for this reason, Christopher, for us to discuss later about the take operation.
Yeah.
Okay. All right. Keep going.
Okay. So now the main design questions that came up were about how to represent their constructors. And there are several ways. One we are proposing
call
here.
Something Lisp. It's totally confusing. I mean, we should call it, Lisp has had many implementations, and it had, there were all kinds of things. It's not a good name. Okay. In any case, that's just a minor point.
Okay. I mean, that's just one of the aliases of that particular constructor, which.
Yeah, okay.
But I mean, it has an official name, which. Okay. So the one proposal is this headdress. So if you, and for each of the Wolfram language generators that lend themselves.
Well, which ones are they? Which ones are they?
Okay, there will be a list later on.
Okay, so, but I mean, it's another one of these things of poke it and see if it sings.
Yes. Now, I mean, we discussed this with Parallelize. Now, my original proposal was indeed something like lazy of range of 1, in infinity, and that is similar to the Parallelize, and that actually suffers from that problem. But here we can easily produce auto-completion on the first argument and syntax coloring.
Yeah, and it's not only this, but also some of these functions, when we take lazy versions of them, they might take additional options to tune them, which usually functions like range just simply don't take.
Yeah,
so it is a bit of an abuse of notation if we put the options in here. But
and there, yes, you can't put them there. Right, you can't put them there. A lot of things will break.
Yes, I mean, the other case which addresses some of these issues, which would be symbols for each, separate symbols for each constructor.
It depends on how many functions there are. I mean, in the case of
there are
parallelism,
about 10 or 12 or so.
Right, in the case of parallelism.
Yes, there it is. I mean, there are about 20 there, and so, I mean, yes, I mean, okay. I mean, it is both of these cases are possible, and we will probably never agree on exactly what to do.
Okay, hold on. You've got a pattern here. I mean, let's imagine that we had a parallelized headdress, okay?
Yes.
And that we just put those functions inside a parallelized headdress and syntax color them.
Yes.
Okay. Then, with appropriate documentation links and so on,
Yes, I mean, it would, especially if we decide on something like that here, then it will make sense to have that, to use
right,
that
but I mean,
same
the
idea
question is,
also for
what
other
else?
part.
Where else could we use the same kind of idea? These are kind of modified versions of functions that sometimes work. I mean, in the sense the compiler can have, I mean, what is the analog of this stuff in the compiler? Of, you know, how do we know if there is a kernel function version, you know, if you say kernel function of blah, does that have the same issue?
No, because there's always a kernel function of blah.
But maybe the other case, I mean, compile of f, for which f's can it actually compile it?
Well,
and not just
for which functions? Okay, this is the question. I mean, go ahead.
Well, no, sorry, I was just going to mention one other case, but it's not very common. Is like CUDA stuff. Be another one where
yes. By the way, Christopher, your audio is breaking up again.
Okay, hold
on.
So, Stephen, anywhere where we want to implement a subset of core Wolfram language on certain
obviously, this is relevant, but that's why I want to have a single pattern for how this works. I mean, again, for net function, that's another place where we've got the same issue, right? Anybody?
Yeah, this is a general thing to basically convert a Wolfram language function into a kind of interface that could have several implementations.
Well, yes, but I mean, my point is this. My point is this. If we can make a pattern for a decorated function, that, yes, I mean, essentially, okay, let's just think about this. These are, yes, you're right. These are different. I mean, parallelized is a different implementation. It's going to give the same result as map, you know, up to side effects, but it's going to be running on different machines. Lazy of range is actually not going to give the same result. It's going to give a different, I mean, you know, in a sense, we could have done this.
Yes, so
we could have done this with sparse. You know, we could have had something where we say, oh, this is a function which has a sparse form, you know, have a sparsified wrapper. But we didn't need to do that because we have a sparse array. I mean, you know, we have sparse array, and then I see the but basic point about sparse array. Go ahead.
We only have one way of creating sparse arrays, or basically, right? Which is sparse array. The other functions, like we have functions like identity matrix, for example, has a way of creating a sparse array, but it's totally weird, right? You say identity matrix of n, comma, sparse array, the symbol.
Right.
So I think that we basically didn't have any idiom there.
Yeah, right. Whereas we could have had an idiom of a sparsified of identity matrix, which would have generated. So we've got two different things here. We've got the parallelized case where the answer is going to be the same, but the operation is done differently. And we've got the other case where which is also what one would want, you know, what one would imagine for some compiled case. We've also got the case that the thing is decorating that function and saying, I'm now going to give you a different return type, which is in this family. Go ahead.
Yeah, I just wanted to say that I think in simple cases, we can get away with not having a dresser and just having like for sparse arrays and things, because sparse arrays are essentially very close to normal lists in terms of what.
No, there's a much crisper thing to say here, I think, which is there is a fallback for sparse arrays, and it's very clear what the fallback is, which is you just enumerate the array densely.
Yeah,
right. So that's the question here. In the case of parallelism, there is also a fallback. You just evaluate it sequentially. In the case of lazy lists, one of the questions is, what's the fallback and how costly is the fallback? And, well, you know, go ahead.
Yeah, I just wanted to say that I think for the case of lazy lists, fallback certainly does exist. It's a list, but the cost
is
in many cases will be very high, unacceptably high.
Right, exactly. So sparse arrays, the cost could also be high, but, you know, and that is a problem. And you know, we you know, if you have a sparse array of length 10 million, that is a problem. For some reason, that problem has not bitten us too badly. Right? It might have done, but it hasn't. Now, I mean, there's another case, which is like the net function case, where you just can't get there from here, is my understanding. Julio or somebody else can speak to that. In other words, if that function is not supported in the net, or another case here. Okay, can we make a list of these, please? Net function is a case. Another case is the database functionality, externalized database functionality, where if you ask, what's that? Net function, yeah. I think it's called that. Are you running?
No, well, it's not called that because we wanted to keep the name for when it had a proper design and functionality.
What's it called now?
Function layer.
Okay.
Because it resolves to a layer. Yeah.
Fine. Okay. All right. Function layer. Okay. So, okay. The other case is database stuff, where there is an operation that is going to be able to be done. And again, we've got this sort of swirling confusion here, because we've got these operations that are, in a sense, it's a select that you can do that actually does something in the database. Okay, I mean, this is the part I don't, I mean, okay. Again, we need this thing where there is a sublanguage that a particular kind of execution framework supports, and how do we know what that sublanguage is, basically? Am I making sense, people?
Yeah, but
and the pattern that you're proposing here is that it is a headdress with essentially syntax coloring that determines whether, that tells you if that's a supported function.
Yes,
that's what you're saying, basically.
Yeah, and not only that, still. But also, this allows you to pass extra arguments, which can be very essential.
I got it.
Yeah.
Right. I'm just saying, if this is a pattern, that is, it's a headdress where we answer the question, does it work with this function by syntax coloring? I think that's a perfectly reasonable thing, but then we should do it everywhere.
Yeah,
right?
I mean, for me, it's of particular interest because I'm right now in the finishing stages of my iterator package, where we have, which is a mutable version of LazyLists, where I run into exactly the same problem. In fact, the arguments for lazy and iterator are almost the same. So if we can solve this problem and decide on something like that.
Wait, how do you use iterator?
Well, an iterator is also a form of a lazy list, but it is mutable. So it is very efficient if you just use the list once, like if you want to do a search over the list or a select or map or something. And the semantics is almost the same as with these immutable lazy lists, but the immutable lazy lists play much nicer with our language because the language is based on immutability. And so the mutable cases, like all these objects with internal state, are somewhat strange, right? Yes.
Okay.
And by mutable, Roman means that if you exhaust iterator once, you have to create a new one.
Yeah, I mean, you're iterating through it. You got to the 11th element in the iteration, and it records that state. You do it again until it gets to the 12th element in the iteration.
Yes,
exactly.
And so it just requires a different form of programming, but it is also a very useful concept, and I think we should have both.
Yeah, that's fine. But I'm sorry, I'm zooming out again. Okay, I want to understand this thing that we've had trouble with in the past. Okay. Of saying we've got a function, it supports a subset of the language. We've got a framework, it supports a subset of the language. How do we deal with that, right? So I would like people to comment here on if we did this approach of having a wrapper and syntax coloring, how that can be used elsewhere. Right, so let's take the example of identity matrix and sparse array. Okay. Could we use something which is, okay, come on, we've got a lot of capable people here. Can somebody please offer an opinion about this? Okay, so
I think with sparse array, the problem is partly that there aren't a whole lot of functions that can return them. I mean, identity matrix is one, but there aren't actually that many.
Right. So your point is so that's a case where it's almost like, well, then that's an option. I mean, I could imagine other ones in, for example, the adjacency matrix of a of a graph would be another example of one that could be quite sparse. And
right now it has some automatic way of determining whether it should be sparse.
right.
But normally the function decides on whether the output is sparse or not. So
I know.
why do we need that argument to explicitly tell it to produce a sparse one?
I guess I'm not quite clear what are you proposing something like sparse as a headdress for identity matrix?
Exactly.
And
that's
then
what I'm proposing. Yes.
Well, so for the linear algebra stuff, not only could that be sparse, but that could be some of these structured arrays as well, right?
Yes, that's a good point. But I mean, so Rob, I mean, this is a good point, and this is why I'm bringing this up, okay? Because if we make a way of doing this, a framework for handling a sublanguage, we should use it everywhere. Right?
I agree. Yeah.
And so the sublanguage you're describing is structured arrays.
Mm-hmm.
Right? But now the point there is that there are two cases of sublanguages. The parallelized case, where the function is happily doing its thing, but there is a special case of the function that has different implementation. That's one case. The other case is in which you are constructing an alien object, like the LazyList case or the structured array case. Right? So two cases here. One case is it's a different implementation of an existing function. So the case that we don't need is the case where you feed it in alien food. And I see, no, the issue is this. The issue is this. If you're going to feed it alien food, you don't know whether it will eat it. In other words, if you've got a structured array, and you give that structured array to determinant, for example, or you give it to flatten, how much do you need to know? Is flatten going to work on that object or not?
Well, for typically flatten will work by, expanding it out.
Well, fine, but so in that case, you've got a fallback that is guaranteed to work.
Yeah, and all the sparse and structured stuff have fallbacks. They guarantee.
Right, but so does LazyList have a fallback? Yeah. Just evaluate the thing.
Yes, I mean the question is, should the fallback be automatic, as in the case of sparse arrays, or shouldn't it be automatic because it will most likely
I know, bad idea, right? I mean, so it's that this is why we've got to catalog. I mean, held functions are another example of a similar kind of thing, where it is a or inactive, for example, is another. If you write that down, please. Inactive is another example where we've got a headdress, and anything can be made inactive. So that one doesn't have a choice. It doesn't have any. Give me some other examples of places where we are, where we want a sublanguage, and where in some cases we've shied away from using a sublanguage because we have no idea whether people are going to know what's in it and what's not in it. Christopher mentioned CUDA.
Well, there was I don't know, see if we didn't write it, but the database operation is another one. If we need to convert a function to something that will work somewhere else.
Yes. I mean, and
it was neural networks databases. Every time we have a sort of a compilation thing where we are not sure that we can match what's happening outside.
Right, but the question then is, let's look at the workflow with which people want to use those things. One approach to the workflow is I write code that is just standard top-level code, and then I say, hey, let me give it a whirl to see if I can parallelize it. Okay, speculatively. Now, I have to say, I don't think people do that very much. In other words, people have so little confidence that Parallelize will just magically do something amazing that they don't try it.
Yeah, Parallelize is, by its name, it promises more than it delivers, right?
So are you saying something, Stephen, like something like we have this inactivate that wraps inactive heads around certain things?
Yep.
So are you proposing something for parallelization where it would wrap parallelized around various things?
That's an interesting idea.
Well, I mean that's what
metaprogramming type of thing. I know, but the point is that that's the case of inactivate is manifest metaprogramming, so to speak,
Mhm.
because you actually get back the expression. It's got inactives sprayed around it.
Yep.
In the case of parallelize, it is not manifest metaprogramming. It is metaprogramming in the background because you don't see it, because all that happens is it evaluates.
Yep.
Yes, I mean, currently, the current support for parallelizability is much better served by this paradigm because there's a specific set of functions.
Mhm.
The original idea, and that's something we can still do at some point because we now have good tools for parsing the input and doing transformations on the parse tree, would be a more general parallelization function that would actually analyze code and maybe find something and do something.
All right, so let's look at these patterns then. So what you're saying is parallelized. I mean, you don't have any kind of sort of parallelized list data structure because you don't need it for some reason. Whereas, I mean, not completely obvious to me why that isn't needed. In other words, the return value of a parallelized of let's say parallelized. Well, let's imagine it's parallelized of range. Okay. I mean, in some world, what's that?
Yeah, I mean, just trying to think. Yes,
Parallelized of range. Write it down. Write it out. I mean, so parallelized of range. One could imagine a world in which parallelized of range would stick a number on different processes.
Yes, I mean, at the moment you can actually do it because it knows how to symbolically dissect iterators, and so it doesn't actually expand them on the master kernel, and so it does some of that code analysis already. So if you have parallelize map of f comma range, it doesn't actually expand the range, but it dissects.
No,
it
okay, fine.
symbolically.
But so you're explaining to me a reason why we could have just like you saying we have a lazy list, we could have a parallelized list.
Well, what would that be something like? And I would imagine that more as like a distributed list, like the result of doing a parallelized range
Yeah,
would
I mean,
be
that would
here's
go
an
in-
object whose data is on 10 different servers that hasn't been sent back to the master kernel. So the
Yes,
next
that's
thing you do on it.
I mean, that's the symmetric multiprocessing, the OMP. I mean, that's the supercomputer type parallelism, which is rather.
Could you just write out the
difficult.
word distributed list, please? Just type it. No, as a function. As a function.
Distributed list?
Yeah, distributed list.
Yes. I mean, that would give us some high-level description of some future symmetric parallelism, symmetric multiprocessing.
But okay, so distributed list, like LazyList, is a. Oh, I see. Connor is pointing out it will be distributed of lists, not rather than. I mean, in the case of LazyList, there's two cases. Could you please write them out on separate lines? No. Distributed list is one thing. Distributed list.
This one, yes.
Function, yes. And then the second thing is distributed of list.
Yes.
Okay. And that is the analog. So in the case of LazyList, you guys are saying there is a base object LazyList, which is not lazy of list. It could be, but it isn't in what you're proposing.
Yes, because we propose the headdress for the operations rather than.
But the actual. So in this case, again, what will be imagined is distributed list is the thing that sits across many processors, and distributed of map, for example, might be the thing that is the version of map that operates. See, this is where we're getting screwy stuff. Okay, because let me go through this again. Okay. Why do we want?
This should work automatically, right? Just like with lazy lists.
Well, I think, Stephen, there are two reasons why we may want the headdress for the operations. One is that
one is to describe what the output is. What is it constructing? That's one reason, right?
Yes, but also, well, that's the third one then, or maybe that's the first one, depends on how you prioritize them. But it also may kind of symbolize that the semantics of, for instance, map may be like normal map, but in certain important aspects, it may differ. because of the nature of things we're dealing with.
What do you mean? You mean differ as in efficiency is different, or what?
Differ as in efficiency, differ as in say which things are computed, or even if, like, mostly.
Okay, but those are okay. Look, we have many functions with method options that determine things much like what you're describing. A method option, though, can't be a small method tail wagging a giant, brontosaurus or something. In other words, it shouldn't be the case that the method tail causes the complete return type of the function to change. But the method tail can be, performance goal arrow, quality, blah, blah, blah. Some of those things, I think, validly can change some of the evaluation semantics.
Yes, exactly.
But they're just method options. They're not giant out in front wrappers.
Well, frankly, I don't know, maybe others would find more things about it, but I think my at least interpretation of this headdress is that we wanted to introduce it effectively to avoid proliferation of new symbols.
Exactly.
So that's its main purpose,
Yeah, right. But I mean, but if that's the case, okay, that's not okay. It's not the only purpose. Okay, let's go through it again, right? One case is we've got a function like range, and range could return, a sparse array. It's not a very interesting level of sparseness, a lazy list, a structured array, a distributed list, all kinds of different things that are different return types. Okay. It could even return something that's some database thing, blah, blah, blah. So one pattern, one model that we have is
distributed is taken.
What is it? What is it? What is it? Mouse over it, please. Mouse over it. Just mouse over it. I don't know. You're not sharing more than one.
Is it like an attribute or no? It's not an attribute, is it?
Oh,
No.
it's
no.
Yeah, okay, fine. It's not a bad name for it. It's not a bad thing for that. It's the collision of English. Okay, go back to this. Okay, so the issue here is, hold on. Okay, some things can perfectly well be constructed. Okay, there are things like structured arrays and sparse arrays where you actually don't want to do the construction and then wrap it. For a graph, for example, you're perfectly happy to construct all those edges and then make it into a graph. In the case of a sparse array or a lazy list, you don't want to construct it explicitly. You only want to leave the symbolic construction, correct?
Yes.
And so, okay, so if you can write this down, that would be very useful.
Mm-hmm.
I mean, one case where we need a headdress is where we are taking a communal garden function like range, and we have, and we are, directing that communal garden function to produce a different type of output, right? So we're changing the output type for a constructor.
Yes, that is exactly the case is that where this whole discussion started, right?
Right. Okay, that's one example. Now, that's one use of this. The other use of this is when certain functions are supported on that type. Well, okay, the certain functions are supported as the parallelized case, right?
Yes.
That's the other thing is a, okay, which is to say, change the evaluation semantics of the function. Have a function with different evaluation semantics.
Yes.
Different evaluation operations. Okay, are there any other cases?
Well, there is that other case which came up with a lazy take of LazyList, right? Take currently returns a normal list, and if you want a lazy list, then you could do it like this. Or there are also strong arguments that take should by itself return a lazy list, and you have to use
Okay.
normal,
Hold on. That's case 2 here. That's the case where we changed the evaluation semantics of a function. I think
we change the output type. It's either a normal list or a lazy
But take
list.
of a sparse array returns a sparse array, Roman.
Yes.
I mean, that's
okay, but the sparse array is kind of invisible. I mean,
well, not completely. I mean, a packed array is invisible, but a sparse array is not.
No, it's not.
Okay. Oh, I see. Oh, I confused the two cases. Yes. Okay. So
right.
So take of a sparse array is a sparse array. So take of a lazy list is another lazy list.
Yeah.
In principle,
by the way, dataset does the same stuff. I mean, I kind of think that there's an argument that take of a lazy list should not be a non-lazy list.
Yes.
And just like with dataset, you know, you can get dataset down to one element, and you still have to say normal to, you know, plop that element out.
Yeah.
I mean, in terms of design principle, I think take of lazy list, returning a lazy list is a good design principle. I never found a case where I actually wanted take to actually return a lazy list, because the default argument of take is just give me the first n elements, and then you really don't need the lazy list.
Roman,
it's just a practical purpose.
Within streaming, I did find all the time, because, for instance, other lazy operations like transpose, I explicitly implement using lazy version of take.
Okay.
And in that context, if take would return things eagerly, that would certainly be a very inconvenient thing for building more things on top of it.
Connor has made another comment, which is about monitored, which is another thing, which is, again, that's a case like parallelized that is.
But monitored
by the way,
is more
another
a wrapper around the whole thing, isn't it?
No, it isn't. No, it isn't.
No?
It's a wrapper around map, for example. Okay. Another case here is supplied, which is another example of where, right? Could you write these down, please?
What is supplied?
I think supplied is different. Because supplied, you don't say supplied of map. You say supplied of the function inside the map.
Right, but the issue with supplied is it's another one of these things where you don't know where there are a limited set of functions on which it works. Because that's what's concerning to me. I mean, like monitored, again, there are actually only a limited set of functions where that makes sense. I mean, you can't really monitored, you know, you might be able to say monitored of find shortest path. We might support that or we might not. You see what I'm saying?
Yeah, this is a general problem for many of these, that we will not have sensible defaults. Like there's not always a case like a sparse array.
Yeah, exactly. But that's why the pattern that we're trying to develop here is, if you know that it is a discovery interface where you say monitored of the thing, and you say, hey, I want to monitor this thing, and you know the thing would turn some funny color, I don't know what, yellow or brown or who knows what it is. If there isn't a monitoring capability for that function, then monitored of that thing would turn some funny color.
We could also introduce a single new Q function that takes a symbol and one of these headdresser, and it tells you if it is true or false that is supported.
That would be useful as well. But I think that's a different case, because I think that more of the time, I mean, I'm trying to imagine.
Yeah, I mean, all the metadata, right? I mean, we obviously have language metadata says which functions work with monitored, with parallelized, with lazy, and so on.
Yes, that's fine. But my question is, as an actual user, okay, let's say that I've got a piece of code and I want to monitor something. I could speculate that, oh, I wonder if find shortest tour is monitorable. Okay, I put it in my code. I type it in. It turns a funny color. It isn't monitorable. Oh, well. Is that a thing one's actually going to do or not? Like echo, for example, I routinely just sort of insert echo at in a piece of code. And that's very useful. And I know it's going to do something. Am I making sense? I don't routinely put parallelize at, because I have no idea if it's going to do something, and
Yes.
it's all, you know, kind of. Now, if I were to put parallelize, you know, of whatever, and the thing would turn funny colors, that would annotate. I mean, this is the same thing I've been saying.
Yeah, I mean, this is entirely doable, right? I mean, even with an auto-completion list and syntax.
Well, I mean, there's even more than that, Roman. If you say parallelize of an expression, I could imagine that we can, you know, in the user assistance framework, that we can actually go in and you know, essentially syntax color, automatically syntax color.
Yes, I mean, this is actually on the table. I mean, and
no, not parallelize, parallelize of an expression.
Parallelize of, yes, where is it? Okay.
Okay.
So, no, this is on the table because, I mean, we discussed that in EC a couple of weeks ago. So I assume there will be a meeting about this at some point. But
well, there's also a framework aspect to this, because, you know, so if I mean, realize that so if parallelized is something that does something, parallelized of map, before that F list is evaluated, parallelized of map is evaluated first, because heads are always evaluated first. So there's an evaluation being done, and presumably you can, you know, you could optionally produce a message if it's not, if it doesn't work, or you could actually just convert parallelized of map to map.
yes,
if it's not supported.
Right, but okay.
Some kind of warning.
Yeah, I mean, that already happens, but just for the other syntax. But yes, clearly, because we have a clear fallback, right, which we don't have for some of the other. Well, actually, why not? I mean, but what would it happen if I asked for a sparse array version of something and there was no sparse array code? Sparse array support.
Well, there's for sparse array, there's two possible cases. One, we say we warn that there's no sparse array version of this, and we do that. Or two, we get the results and try and make it in a sparse array, you know, post.
Yeah, it might not.
But if it's not an array itself, it may not work.
Okay, let's okay. So the main point here is we've got a family of issues around, number one, different output types for a constructor. Number two, changing the evaluation semantics for a function. And it seems to me in the lazy case that the second one of these of changing evaluation semantics is not what we're really into here. What we're really into in the lazy case is purely changing the output from a constructor, and that it's always lazy to lazy, and that should be our general principle, like it's sparse to sparse, graph to graph, data set to data set, and that it always is the case that you call normal in the end if you want to reduce it to a normal expression. Lucas on our live stream is commenting that in graph construction, lazy graphs will be a lovely thing to have. Yeah, well, you see, that's a good reason to have. That's a constructor. Okay, is a question. I mean, okay, hold on. In this proposal, you've got lazy lists. Why aren't they lazy arrays? Why can't they be multidimensional, for example? Why can't they be lazy trees?
They can, and this is exactly why lazy is going to also be used here as a generic constructor.
No, it's not a constructor then. It's not a constructor. We got to be clear. Look, one thing is, well, maybe it is. Okay, what we were distinguishing before, sparse array is a head that represents a sparse array. Okay, it's not sparse of list of blah, right?
Yep.
It's its own thing. And what I had understood here was that lazy list in your design was in some sense a base object that lazy of range produces.
Yes.
Yes.
Okay, but so then an array, okay, so what I'm asking is those base objects that get produced, is there also a lazy array and a lazy graph, a lazy tree, or what? Because you can't get away with saying, no, it's just lazy of tree.
Yes.
That's not going to cut it. Okay.
Yeah,
I
that will
think there
be
has to be a lazy each of them because the semantics are so different.
Yes, I mean, we discussed this in the multi-computation meetings, and our feeling is that if we go for full generality, then this will never happen because the lazy list case is very useful by itself, and it does not preempt any other lazy.
Okay, but so here's a question for you guys. Okay, given a lazy wrapper for range or a lazy wrapper for table, for example, how do I determine whether the thing that I'm producing from lazy of table is a lazy array or lazy list? Do you see what I'm saying?
Lazy, what do you mean by lazy array?
I mean the higher dimensional analog of a lazy list.
Mm-hmm.
With its own complicated semantics of evaluation fronts and so on. I mean, by the way, I do think that a lazy array is an interesting construct, which I think will reveal a bunch of things about evaluation fronts, which is the thing.
I mean, at the moment, the only way to do this would just be nested. I mean, the elements of lazy lists can, of course, also be nested lists.
I understand that, but I mean,
but that's not the question, right? The question is whether there is an unambiguous way to specify. I mean, one way we could do is to specify it via some kind of option, but that's bad because
I don't like it.
Typically functions should not return different return types based on options.
Exactly. So the point is that lazy here, your concept here has been lazy produces a lazy list. It modifies the constructor function to produce a lazy list. But now we've got this horror of, well, actually, there are a lot of other lazy structures too.
Yes,
well,
but I mean,
sorry, go ahead.
No, I mean, we don't have to cover everything in this proposal. I mean,
no, I know, but we need a design.
Lazy lists are useful by themselves, and if we do it correctly, then this will not preempt anything else.
But it does.
That's not the question, right?
Put lazy wrapper around range or around table. What is it returning? Is it specifically returning a lazy list, or is it returning?
I see your point. Yes.
Right. And rather, it's almost like we need the headdress. I mean, I suppose we could have something where lazy defaults to returning a lazy list if it can, where lazy is a little bit heuristic in what it returns. It returns the obvious lazy structure, but inside lazy itself, one of its arguments is basically a forcing of what structure to return.
Yeah, so that's for the case of multi-dimensional tables. Yes, now I think I understand. Yes.
Right. So in that case there, the question is,
I see the point, yes.
Right.
Well, but the problem is, I think you want it, I think doing kind of magic automatic stuff like that can be bad if the operations on the results might be different, right? So if you run that and you don't know, is it going to return a lazy list or a lazy array object? If your code, like if code expecting a lazy list will fail on lazy array, then I don't think you want it to flip-flop like that.
Right. I agree.
Better just to say lazy list or lazy array when you make it.
Well, quite. But we've now got two uses. We've now got a segregated headdress for lazy list and lazy array, and that's weird. Right, then we would need it.
Why is that weird?
Well, we'd need both a headdress form and the object form, right? We got lazy list. No, I don't think that's going to work.
But sorry, I don't understand exactly why. Well, so okay, so I guess the argument is that, you know, if we had a sparsified, you wouldn't say sparse array of range of blah. You would say sparse arrayified or something like that of range of blah. Is that kind of the argument?
That's what I'm saying. I'm saying that if we've got to segregate the wrapper, so what you're doing there, Roman, it doesn't make a lot of sense to me, because lazy list is the constructed.
Yes, but I mean, I was just trying to disambiguate if there are.
I know. Yeah, that's
so
my point.
If lazy is too general, then we could use lazy list to say, give me a one-dimensional lazy list.
No, we can't, because lazy list is itself. That is not the same thing. That is a
Well,
it will be called
it-
LazyList Operator. To type in LazyList Operator there of
Right.
table.
It's probably not actually ambiguous. You probably could make it
No,
work like this. It's
I
just
mean,
that it
it
might
could
look
work
weird.
because, I mean, the lazy,
I
the
know.
lazy, just like association, which is its own constructor.
Oh, or another
it's
version
like-
would be to have a first argument of lazy always be the type, like list, and then the other things.
Yeah,
like
but then if
lazy-
you're doing
don't wanna
everything
do
with
that. We
lists,
don't wanna do
and you're
that. We don't wanna
constructing
do it.
things, it's going to be quite
No,
ugly.
no, no. Just type it as a single thing. LazyList Operator with a capital O.
Okay.
Case thing.
Nice.
That's a LazyList Operator of table.
Mm-hmm.
Okay. That's the
Look,
full form.
critically, no
Mhm.
operators will be in this. It'll only be constructors.
Now, of course, there's
Okay.
another way to
Okay, so actually, yeah, we'll write
do it.
constructor instead of operator there. Right.
LazyList constructor. Okay. Yes. Now there's another way to disambiguate, and that is because if, I mean, the default or the standard implementation of LazyList just supports one-dimensional ones. So you would have to use a different, what we call backend or different implementation, which could support multi-dimensional lazy lists.
Sure, but Christopher's point is,
Mhm.
it better not be the case that if you diddle with the options there, that you turn it from something that the outer functions around this thing can eat it
Mhm.
to ones where it's poisonous.
Well, the functions that operate them, they switch on the type of the argument. So if you provide an implementation of multi-dimensional lazy lists, then you also need to provide your versions of all the functions like map and select and so on.
Well, but then you just blew up the whole idea, right? Because the whole point here is you're not going to be able to provide every single function in the system, right? What's it going to do if you say determinant of a lazy list? What's it going to do? What should the system do in that case?
Well, it should just give an error message, because I mean that's not the.
Okay, but how do you discover? That's the exact problem we're talking about.
Mm-hmm.
How do you discover, pecking at things? Oh, can I make this? Can I do a subset map on this? Will it stay lazy or not? Right? That's the problem that we're having.
Yes.
That's why parallelize fails, is because you have no idea what's going to work and what's not going to work. And in the case of laziness, if you're trying to write a piece of code and you've got to run the code every time, say, oh, did this work? Did this not work? That's the problem we have with the compiler. It's disastrous. You've got to know, as you type the code, is it going to work? I mean, better that you have a simple cognitive model that tells you in advance whether it's going to work or not.
But Steven, there are two problems here that we are trying to solve at the same time. One is whether this headdress idea can help with this sort of discovery of things, in addition to other things. And the second is what happens if you have several objects that can be potentially produced, and you need to somehow distinguish which one is going to be.
Right.
But I mean, for the question of which operations are supported, I mean, we have the same problem for standard lists. I mean, if you take transpose and it's not a rectangular list, it will just produce a message. There's no way to discover that upfront. And so each data type, just like dataset has a number of operations that work on it. Others don't. You don't know upfront whether it works or not. I think that's a general problem. Each data type comes with a set of functions.
I understand it. So I'm saying that's a problem which I consider to be fairly devastating for some of these situations.
Yeah.
And I really would like to have something where the interface is such that we can syntax color at the moment of typing, so you already know whether it's going to work. Just like, imagine you're trying to write a piece of code that's compilable, and it's syntax colors. If you type in the function, I don't know, subset map, for example, and it's syntax colors saying, I'm sorry, that's not compilable, then at that moment you have some chance to say, oh, I'm going to rewrite my code in a different way. By the time you finished writing it and you built it all around subset map, and then it says, sorry, I'm sticking my tongue out, it's not compiling, you're just annoyed. Am I making sense?
Yes. But
yeah.
Right?
Here's a completely different idea. What if, and it's not as tidy, but suppose you had something like, if you did constructor of table rule lazy list, and that was the headdress with the rule, the thing that table is supposed to return.
Yeah.
I mean, it's not as tidy, but it solves that problem of the type specificity.
I was actually going to suggest something very similar.
But how does that relate to, Christopher, the compiler, when it has a type specification in a compiled thing? What does that look like? I mean, it says typed of blah, blah, doesn't it? To represent a function that returns.
Yep.
Go ahead.
Yeah. I mean, you say, yes, you can use type, or now you use type hint if you want to tell it, some object in the middle of your code has a type.
I mean, it's a little weird, but I agree that this is, fine-grained control over types of constructors. So, I mean, one possibility is that lazy just sort of.
Lazy is too general.
Let me make a comment here. I mean, this is one of these design judgment things, which is always difficult when, in a case where we don't really have experience with it. Like, a famous one that I was just writing about yesterday, whenever it was, is the x = x+1 design decision. Right? People said, back in 1979, 1980, about SMP, people said, this system is theoretically impossible, it'll never work. People will run into x = x+1 all the time, it'll blow up all over the place, and nothing will work. Turns out that was wrong. Turns out x = x+1 is a corner case that isn't important. So the thing that I don't know here is, let's imagine that we have lazy and that it sort of just does the obvious thing with, as a headdress of a function. Is that going to be good enough? Or is it going to be, are the corner cases of where you don't know whether lazy is going to return a lazy array or a lazy list? Are those obscure and nobody will run into them? Another famous example is up values. The fact that up values are only one level is another thing where it's like, that could be, yes, we do run into trouble with that, but it isn't a front and center blaring, this is unusable type thing. Am I making sense? And so the question here is, what is this case? Is this case a case where most of the time, it'll be okay to just say lazy of the thing? Or, and maybe the right answer is that we, most of the time we just say lazy of the thing, and because let's imagine that it's a graph that you're constructing. You say lazy of graph. What is it going to do other than make some kind of lazy graph? Am I making sense?
Yeah, and I would also argue that the LazyList case, the one-dimensional LazyList case, is by far the most important. And the lazy array and multi-dimensional and stuff like that's the corner case.
Yes, but on the other hand, in terms of the, how do you say, for the design to be consistent, we don't want randomness, like sometimes this is this, sometimes this is that. So we really want, I think, some clarity that this is very clear what is going to be, what is going to speak out.
And if we have syntax coloring, okay, or some syntax highlighting thing, and you say lazy of table, and it kind of flashes up a thing that says lazy list or something somewhere, then we kind of know what's happening.
And how would we create lazy array in that case?
Well, we'd have to say lazy of table arrow lazy array, or some such.
Oh, okay.
I'll just mention, until we introduce packed arrays, and an array in Wolfram was always a list of lists of lists. So why isn't a lazy array just a lazy list of lazy lists with some sort of dimension?
Yeah, okay, it's more complicated because there's an evaluation front. You don't know where the evaluation front is.
Yeah, well, but you can still have that with lazy lists of lazy lists. I think it's more just an efficiency thing.
You could, yes, you could, but the whole point of laziness in a the non-trivial point of laziness in an array setting or a graph setting, I hadn't really thought about lazy array. Lazy array is a simpler case than the lazy graph case, than lazy evaluation of a graph. It's a special case of that. Okay,
Well,
I kind of like
but actually, I would
this.
argue that the lazy array. I mean, right. I mean, the few times, like for example, the summer school and things that we've had people do lazy arrays, the useful lazy array is much more of a linear algebra object. It's like something where you give it an equation for each element. You say, oh, given this is the index, this is what the element should contain. Which is, which I think that would be the useful lazy array, which would have totally different semantics.
I agree.
That we can actually do with a structured array type of thing too.
Yeah, lazy array may be a corner case. Lazy graph has its own uses that we've discussed at length in multi-computation.
Yes, I now think we should be clear in the constructor. That's where you have to make up your mind what you want, right? And so having a constructor which clearly indicates the type of operation like this is preferable to just lazy, which is to.
I don't agree with you. I don't agree because I think people are going to have to type it all the time. And I think I'm getting convinced that in fact, so long as there is feedback when you enter the code, that it's probably okay, because the 95% case is going to be lazy lists. And the other case is kind of when you say lazy of graph, you know what you're going to get.
I mean, we could certainly have both. I mean, this one would be the kind of
the official version.
The official version. If you write a piece of code that you want to sell or so, you better be very specific. But if you type something interactively, then you will be more than happy then that the short version will just give you what you expect.
This is a beginning on this. So then the concept is lazy list in the current thing that we're planning is the only object that comes out, right? There's no other object that comes out.
At the moment, yes.
Okay, fine. So in the future, there might be lazy graph and so on, but those will come slowly, just like graph and tree and so on are, are slow to come things because there's a lot of baggage associated with them, or around or something like that is a slow to come new object. Okay, so fine. So then I think we've got an idea here how this works. And so I think the concept is that for the constructors, it's a lazy wrapper and it'll syntax color to tell you whether it's actually going to work. You can have all kinds of options and things beyond that. Okay, let's go on in the few minutes that we.
Okay, so here is the kind of basic list of constructors. I mean that the set is small. There are some other ones, especially the combinatorial generators, which are useful. So we don't have to look at the alternative proposal because we just discussed that at length. I would like to just mention the kind of other conceptual idea. There's one idea of hooking up external data sources to lazy lists, like files, databases, that would make them available with the same user interface as built-in lazy lists. So that's another thing that is part of the proposal. And
okay,
then
so
of course,
hold on.
Yes,
hold on.
okay. Yes.
Lazy of permutations, I understand perfectly well, right? And I'm a little bit confused that lazy of map indexed and things like that should be things, shouldn't they? Go back to the previous page.
Okay.
Where's lazy map? Oh, no, I see. I see the constructor. I see.
Map index is not a constructor.
No. I understand. Okay. I understand. Your point here is that what makes this worth constructing is something like range or table or nest list, where you give a number and it, generates a thing, where you're giving a number and it is coming out with an instantiated thing with that cardinality.
Yes.
Right. So it's sort of cardinality, and you might make a note of this. It's kind of the cases of relevance are cardinality in these things here are mostly cardinality in and something out.
Something big out, yes.
Right. Now, nest while list is an example of something different from that. That's not a cardinality-based function. That's more like an, ordinal test-based function. Are there not others of those?
Yeah, I mean, these three are useful to have, but I mean, they are just syntactic sugar because you can always just start with nest list.
No, you can't. No, you can't. Not for nest while list. Nest while list, you have no idea how long it's going to go on. And by the way, nest graph is a, I mean, if we had lazy graphs, nest graph or nest while graph basically is the quintessential go on. I mean, nest while list is different from the other ones here because nest while list is of unknown size.
Okay, we need to talk about this again. Yes,
but Steven, we for lazy lists at least, this should be fine because lazy lists are not necessarily need to know.
I understand that. I understand that. I'm just trying to understand what functions are really part of this gaggle of the portable constructor functions.
Yeah, we didn't intend to have a full list. They are rather representatives.
Okay, but then, okay, let's talk about read list, okay? Because I consider that a quite different. And by the way, random real, random integer, those are pretty complicated because they have state information. You know, yeah, okay, so they are examples.
Yes, I mean, these are stateful, so they would.
I see.
They would normally. I would suggest to use the iterator interface and not the lazy list, but the two are actually can be converted. The
problem is you can't get the millionth random integer without knowing the previous random integers.
Yeah, but that's true for most lazy lists.
Not for range, it isn't.
No, not for range, but I mean for select and.
Okay, I've got another example here. Real digits. Is that an example?
Yes. Yeah. Real digits, yes. Integer digits, yes. Yes.
Well, maybe integer digits as well, but real digits for sure. Real digits of pi.
Yes.
Is you know, lazy as could be, so to speak.
Yes, no, that's a good point. Yes.
And I wonder if there are more functions like this. I really think we should shake this tree and make sure we have all of them.
Yeah, we should, but I mean that's not the first thing we need to do because once we have a proper design, then we can.
Right, but I want to make sure that the design, like for real digits, okay, it will be lazy of real digits, and I think that would probably work. Where we say comma infinity, we say lazy of real digits, and then you know, like range, for example, in its lazy version, lazy range of infinity is going to just work.
Yes.
Whereas lazy range of infinity on its own will give a message.
Yes.
Okay, fine. So let's go now to the next page.
Okay. So
Steven, I just wanted to make okay. So
Leonid,
very quick comment.
If you okay, go ahead.
I want to talk about read list actually. Were you about to talk about read list?
Partly, yes. I just wanted to say that we have to distinguish between functions which are essentially sequential and functions which allow some kind of random access.
Indeed. And sometimes it's complicated. Like the digits of pi, we thought they had to be sequential, but actually there's a random access algorithm for them. Similarly, you know, a lot of those combinatorial generators, the naive thing is that they're sequential, but in fact, there's a random access method for them.
Exactly, and random access can be very, very useful if it's allowed, if it's possible.
Right, but so some of these things we might initially implement them sequentially. I mean, even for random integer, there's probably a random access for certain kinds of algorithms. There is a random access method there. Okay, but let's talk about read list because I don't quite understand that one yet. So the issue is, you know, to me, import is the more interesting function. Because import, okay, read list is a more low-level thing. Let's talk about import, okay? Let's say you're importing.
Steven, we have an example exactly about this here in the set of examples where we're importing from a file, but we are able to do that in a kind of random access-like way.
Using seek.
Using seek, essentially, yes. Pre-processing files to first get certain positions of things, and then skipping records to only basically read the part of the file we're interested in.
Okay,
and doing that
I don't understand the semantics. So I mean, let's say you've got a thing in the outside world. Okay, let's take the most simple example. Let's take get as an example. Okay. Can we have a lazy version of get?
Well, with get is complicated because it evaluates things as it reads them.
All right, well then let's say binary deserialize. In other words, what I'm saying is you've stored in a file, or here's an example. Yes, this is a better example. Lazy resource data.
Well, with certain serialization formats, that should be possible.
No, but let's take lazy resource data as an example. You've got a big data set out there in the data repository, and you could just say gulp it all in to memory. But no, I want it to be lazy. And I only want to, only when the evaluation requires a particular thing to be read, do I read it.
Yeah, it's totally fine idea. And actually, even back in streaming, I had something similar, and we certainly plan these kind of uses here.
Right, but so let's just understand what that is. That is an out-of-core data set, basically. That will be, for example, an out-of-core data set. Or here's another example. Here's another example for your collection: images. Okay, with dynamic image, there is this idea of images, videos, all kinds of things like that could be lazy too. You could have
Absolutely.
something.
Yeah,
and in a sense, the video interface right now is sort of a lazy interface.
I mean,
that interacts with the out of
yeah,
core.
that's the out-of-core type laziness, which is supported by Leonid's stream package. So I think we can.
Right, but I just want to understand what there's a thing where it is an unwashed mess of let's say binary data that represents some Excel file or something that's in binary form externally, and you say I want position A17 in that. That's a slightly different story, because that the laziness transducer is more complicated in that case.
Sure. And actually here, in this example D, I'm using something very, very simple, but of the same kind of type, because basically you're specifying a separator type, and then it goes through the binary data, looks for those separators and splits out, like pre-processing things in a very quick way. And then it figures out which records are there, like where are the borders of those, and then it can read sequentially or randomly certain records only.
Right. Well, okay. So I mean, just the basic interface, and we need to wrap this meeting. But the basic interface to this thing is there is a. What is the constructor in our?
Can we scroll up?
Yeah, and in our kind of thing about constructors versus other things, is it the case that this is a lazy file, or is it a lazy of? See, this is what I'm confused about.
Roman, can you switch to a different page where there was this, the next one?
Yeah.
No, the next one.
Next page.
The next slide.
Page.
Okay.
We have here this proposal that you basically have lazy list of something. And so basically that something can be either a file or something else. And it's lazy list that basically converts that to lazy.
I understand, but there's two possibilities here. One possibility will be lazy of import. Maybe you can write that down, Roman.
Mm-hmm.
Lazy of import, which is a constructor that returns something lazy. Right, that lazy of import, I think, is directly analogous to lazy of range, I claim. That's
okay.
case number one.
All? No, not all, but there's plenty of formats that do have represent a sequence of values, right, where this makes sense.
Yeah, right.
Okay.
Plenty.
Mm-hmm. No, that's. I mean, import export is. Export as well, right? I mean, exporting from a lazy list in an efficient way or so.
That's less clear to me.
Mm.
That's clear. But lazy of import is clearly a constructor-based way to get laziness.
Yes.
Okay. Now you've got a different idea here, which is you are holding you're holding a handle, for example, to a file. And you're saying, rather than, because often with an external file, it isn't naturally in an expression format. Import tells you how to transduce from whatever external format there is to an expression format.
I mean, there's a useful case which translates directly to laziness. That is readlist, where you can specify what the things are. And
I know, but it's not a very widely used function. I mean, import is a much more widely used function.
yes,
But the quite different thing would be something where you actually, produce, like I've got many examples where I have generated a gigabyte-sized thing that is a Wolfram language expression. I mean, okay, here's another case. This is lazy, and I don't quite know the semantics here, but it's basically lazy cloud expressions. Lazy, lazy. What does that look like?
yes.
Because a lazy cloud expression is something where it is an expression, but it isn't in memory, and you only lazily want to pull it into memory.
Cloud expressions are already lazy, aren't they? Kind of the way you access them.
Yeah, but there are
yes.
There are 2 degrees of, like, 2 ways you can do that. You can, for instance, you have a data source. You can either immediately convert it to something which might still not be in memory, but already in some sort of dissected converted form.
Yep.
Or you can even say, no, just do it sequentially as we need it. And that's why here I was using, we were using this as a proposal. It's we don't know how to make it really the good syntax here, but you can have data source or lazy data source. So you can have either data source which is kind of immediately converted into something, or data source where you say, no, keep a handle and just do things as you need it.
I understand. You've got look, there's 2 cases here for external stuff. I think you're basically saying this. One case is it's already an expression. Binary serialization, cloud expression, whatever it is, right? It's already an expression. The other case is there is transduction that has to happen to make it an expression. And that transduction needs an additional operation, which is, if I ask for the 10,000th element, can you reverse transcribe it, so to speak, to find out where that is?
Yeah, and it can be also a hybrid case where basically, imagine you have a file, you have a handle, and you construct a lazy list out of it. You've already read first 1,000 elements, so that part is sort of already in the form that can be consumed without any further reference to that handle. But if you want to read more, then you use that handle and you sort of do the proper necessary operations to fetch another 1,000 ones.
Yeah, I get it. All right, we're making progress, guys. Let's please not wait too long. Maximum of 2 weeks for another meeting.
Steven, I think we are ready to continue with this because we have a bunch of other things in this design which we didn't have time to discuss today.
Okay, fine. Well, then set something up as soon as possible.
Well, I mean, I would like to go over the points we raised today, but I mean, the thing we didn't get to, which will certainly also cause some discussion, is the set of functions and special cases of functions on lazy lists. But,
no, I think that what we're agreeing is that it's always lazy to lazy. Nothing resolves except normal.
Well, I mean, there are obviously those functions that return a single value, like first.
No, I'm sorry. It returns a lazy single value. I see.
No,
your point is your point. Wait. Your point is this, which is what we haven't done with dataset. Okay, dataset, even if it's a single value, maybe it as an exception for a single value. The issue is, does it return a list? If it doesn't return a list, you can't put a lazy wrapper, you can't wrap it in a lazy list. If it's actually if it's a determinant or something, and it's going to return a number, you have no choice but to return the raw thing, unlazified. Right?
Now, with the way of access to lazy lists, I mean, it is really important to understand whether a function just requires usually very few elements of the lazy list to produce a result, or whether it is essentially a loop, like last normal, that would consume the whole lazy list. So
yeah,
so yes.
This, and also, Roman, can you scroll a little bit up? There is this classification of operations. No, actually, it was almost there. The one below, like the classification depending on the like eager, lazy, and terminal, non-terminal. Can you find that place? It was already on screen. It was just partly visible here. So I don't know if still we didn't discuss it today, but there is this classification which we think are important.
I think that's sensible. I see the first thing there. You know, there's no choice. Now, the only issue is if there are new lazy data structures that we introduce, where something that you say, oh, it just returns a value. Right now, the value it returns, oh, it's going to return a graph. Okay, well, we don't have a lazy graph, so we have no choice but to return an eager graph. But in the future, it might be able to return a lazy graph. So that's one issue there. Probably a minor issue.
We planned to use lazy keyword to also force, or maybe some other, to force the behavior. So if it's take or part or something like that.
I understand, but that's a different thing. That is a non. Okay, we've got more discussion to.
Sure.
We can't do this right now, unless we move around a bunch of stuff here.
No, we should have an internal meeting first, and then we can come back.
Okay, all right,
absolutely.
Okay. This is good. This is making progress, and you know, I think the main message here is you know, there is more. You know, there's a little bit more broad thinking about what can be lazy, like resource data and so on. All right, we should wrap up here. Thanks, guys, and see you all another time.